welcome to Tutoring with Tiana. I hope you are doing well today. We are going to be talking about factoring, specifically factoring with GCF or your greatest common factor. I am going to share my screen and then we can get started. So I'm just going to go through a couple of examples of the different types that you can run into when factoring with a greatest common factor. Another way I like to refer to this as reverse distributive property. So you're basically just trying to figure out what is the largest number that you can take out, and if there are any variables in common, like how many of them do they have in common? So for instance, in our first problem, we have 6x plus 9x. So if we're looking at just our numbers portion, we're focused on our 6 and our 9. The greatest common factor between 6 and 9 is 3, so we can pull a 3 out of both of them. So we're going to put that guy on the outside. Now we're going to focus on our x squared and our x. There are two x's that live here, and technically there's a 1 up here, right? So technically there's 1 here. They only have 1 in common, so I'm just going to pull out an x. Now, I'm going to fill in my parentheses. I have to think about what is going to make it true. So how do I get a 6x squared down here, and how do I get a 9x down here? So we're going to fill in our values accordingly. So 3 times 2 would give me the 6, and then x times x would give me an x squared, right? We're still doing addition between, so we're going to keep that guy there. And then same sort of idea. 3 times 3 would give us our 9. We already have an x here, and we have an x here, so we don't need to add anything else. Our final answer would look like this. Okay, let's move on to our next type. So similarly, the first thing we're going to look at is our numbers. So we have a 12x and an 8x. The greatest common factor between these guys is a 4, a lot of 4 from both. And then again, we have x cubed and x squared. There are 3 x's that live here. There are 2 x's that live here. So the most that we can pull out is the 2 that they have in common. So we would get x squared on the outside. Again, we're going to draw our parentheses in. We're going to leave our minus between them and then just try to get back to our original problem. So again, 4 times 3 would give us our 12, and then x squared times x would give us our x cubed. 4 times 2 would give us our 8, and then we already have x squared and x squared in common, so we don't need to do anything else. And this would be our final answer here. You don't really have to write this portion underneath. I just like to write it when I'm first teaching it because I feel like it gives you a good visualization of like where you actually want to end up. Let's move on to our next one. So this guy might look intimidating because you have an X and a Y, but we're still going to do the same thing. We always like to focus on like one thing at a time. So we're going to focus on our numbers first, then we're going to focus on our X's, and then we'll focus on our Y's. So if we're looking at our numbers again, 15 and 20, greatest common factor is 5. And then if we're looking at X squared and X, we can pull out 1X, right? Because there's 2 here and technically 1 here. Then now we're going to look at our Y's. We have 1Y here, and we have 1Y here. So we can pull out a Y as well. We're going to draw our parentheses, keep the addition between, and figure out how to get back to our original problem. So 5 times 3 would give us our 15. X times X would give us our X squared. And we already have a Y here and a Y here. So there's nothing else that we need to add. Let's move on to our next term. So we have 5 times 4 would give us our 20. We have an X already, and we also have a Y already. So we know that we're done. And this would be our final answer here. Let's move on to our last example. We are going to do the same thing that we did before. We're going to look at our numbers first. Greatest common factor between 14 and 21 is 7. Greatest common factor between x to the fourth and x squared is x squared. And then we're just going to fill it in to make it true. So 14x to the fourth and 21x squared. 7 times 2 gives us the 14. X squared times x squared would give us our 4. So our exponents need to add to what we're looking for. And then 7 times 3 would give us our 21. Then we have x squared and x squared here. So we don't have to do anything else. And this would be our final answer. I hope these examples made sense. I do want to hop back up to number 2 and just show you what we would have to do if we didn't pull out our greatest common factor out of this guy. So for instance, let's say we started with the 12x to the third minus 8x squared. Maybe we said our greatest common factor is 2, right? Maybe we didn't think that it was 4. We couldn't think of a number besides 2. We can always start with 2. Right? And then let's say we knew it was x squared between our orange portions. So we're going to pull out an x squared. When we fill this guy in to make it true, we're going to get 6x, our subtraction stays, minus 4. Right? And technically, this is a version of the original problem factored, right? But we're really looking for our greatest common factor. And the way to be sure that we have factored out our greatest common factor is to look inside of our parentheses and see if there's any number that they still have in common or any variable that they still have in common, right? So if we look inside of our parentheses now, in here, we can see that they have another 2 in common. So we need to pull that 2 out also. So just from our parentheses, we're going to get 2 times the quantity, 3x minus 2. And then we need to bring these guys down. Right? And now you're looking at this, you might be thinking, what am I supposed to do with all of these numbers that are on the outside? So between all of these numbers is multiplication. So remember, when you have a number next to a variable, it indicates multiplication. So when we are going to write our final answer, we would want to combine all of our outside numbers. So 2 times 2 is 4x squared. And then our parentheses would stay the same. And you can see that we get the same answer that we got here. We just have one more step in between because, we pulled out 2, we didn't pull out a 4. But that's always a good way to double check that you have pulled out your greatest common factors, to look inside of your parentheses and make sure that they have no additional common factors between them. So I hope this made sense. We are going to move to some problems that you can try on your own. So I'm just going to pop up these 2. I will let you solve it. I suggest you pause here and give it a try before I give you the answers. Okay, so we're back. We're going to look at our numbers first, right? So we have the 10 and the 25. They have 5 in common. Looking at our x squared and our x, they have x in common. And then keep the plus between. To make it true, this is going to be 2x plus 5. Is that what we got? Okay. Let's move on to number 6. Again, we're going to look at our numbers first. This one's a little bit tricky. They're both even. So you could pull out a 2, but we want the greatest common factor. So what is the biggest factor they have in common, right? So in this case, it's going to be a 6. And then if we look at our x's, we can pull out an x squared. And then we have to fill it in to make it true. So it's going to be subtraction between still. And we get a 3x minus 1, right? Because we don't need to add anything else into our second term, but we can't just leave it blank. So we put a 1 there. So remember, we're doing reverse distributive property. So if we were to distribute this back out, we would need to multiply to something to get our 6x squared. Okay, I'm gonna let you take a look at 7 and 8. Pause here. Okay, I hope you've paused and had the opportunity to do the problem. We're gonna look at our numbers first. So the 21 and the 14, greatest common factor is 7. Between x squared and x, greatest common factor is x. Between y and y, greatest common factor is y. I'm gonna draw our parentheses, addition stays. And then we're going to fill this in with 3x, right? Because we already have the y, we don't need another one. And then plus 2, because we have the x and the y, we don't need another one. Doing good so far. Let's take a look at our last one. We're going to look at our numbers. Again, this guy's a little bit tricky because they're both even. So you could pull out a 2, but again, greatest common factor, right? So we're going to pull out a 4. In this case, when we take a look at x to the 4th and x squared, we're going to pull out an x squared. Inside of our parentheses, we're going to keep the subtraction. And then we get 2x to the 2nd. Remember, we want our exponents to add to our original. And then we are going to get minus 3. So those were all of our practice problems. I hope you got all of them right. If you need to, take a look at the previous examples and try them again if you did not. But I hope this video was helpful. I'm going to have a whole factoring series. This is just part 1. If you're going to be factoring quadratics, we'll also talk about factoring perfect cubes later on in the series. But I will see you in the next one. Thanks for watching. Bye.